All right, so again, GCF is the reverse of the true property. You're going to put one set of parentheses with that GCF in front, and then to get what's inside your parentheses, you're going to divide each original term by the GCF to get what's inside there. Okay, and you can always double check your work. Once you did factor out, you can do a quick in your head distributive property and see if it does actually equal. And so again, you can write those two example problems down as well. So as we said, again, GCF is always the first thing you're looking to do. That's why it's at the top of our flow chart. For checkpoint A, is pretty straightforward. That's like the GCF you've been working with in the past. Okay, so if we look at 10x to the third and negative 4x squared, we're saying what number and or variable would divide into all the terms. In this case, there's two terms. So what number and or variable divides into both those terms? Right. So 2 divides into 10, 2 divides into 4. There's nothing larger that divides into both those. And also, x squared divides into both of those terms as well. So when you're talking about exponents, you always want to look at the lowest exponent. Our lowest exponent is x squared, and so that would be our GCF. So as we said, we're putting our GCF in front. We are making one set of parentheses, and then we can divide each of our original terms by our GCF, and that's going to get what's inside. So since we had two terms to start, we're going to have how many terms inside the parentheses? Two terms still. Okay, so 10x to the third divided by 2x squared. 10 divided by 2 is 5. X cubed divided by x squared is x. So I go and look to my second term now. Negative 4 divided by 2 is 2, and the x squareds cancel out. If I do a quick distributive property just to double check, 2x squared times 5x is 10x to the third. 2x squared times negative 4, sorry, 2x squared times negative 2 is negative 4x squared like we wanted. So we just pulled out the GCF and factored that. Now for part B, it looks a little different, but it is still really the same thing. There is still only two terms. Remember, terms are separated by addition. So there is a term to the left of this multiplication here. There's a term over here on the right side of the multiplication. So we have two terms in this particular problem. And what is in common in both of those? What's a factor that's in common in both of those? Remember, factors are separated by multiplication. So this has a factor. Remember, there's multiplication here and here. So this term has a factor of x minus 7, and this term has a factor of x minus 7 also. So they each have an x minus 7. So it's a little different here where they were just kind of like one term. Now this actually is a factor that's going to have two terms within it because it's in the parentheses. So our GCF is x minus 7. So I'm going to put x minus 7 in front of one set of parentheses, like we said. And then to get what's inside here, we're dividing each of our terms by our GCF, which again we said is x minus 7. So when we do that, the x minus 7s would cancel, and we'd be left with 2x as our first term. And again, the x minus 7s would cancel out here, plus 3. And then when you do that distributive property, you get 2x times x minus 7, and then 3 times the quantity of x minus 7. Okay, so that's probably a newer piece of that GCF for you that you definitely didn't see in Algebra 2, depending on what class you took already. All right, so I want you to try these two GCF problems as well. So try those two on your own. All right, for number 8, what do we have as our GCF? 2x plus 1. So I'm putting 2x plus 1 in front of one set of parentheses. We divide everything by 2x plus 1. And we would be left with x plus 4 in our parentheses. All right, for number 10, what would be our GCF? No, what's our GCF? Good, 2x plus 5. That's going to go in front of our one set of parentheses. We divide everything by 2x plus 5. And we're left with x squared plus 17. All right. All right, so that is our one type of factoring, GCFs. Our next type of factoring that we're going to look at that you were done a ton of problems with in the past with in Algebra 2, I know for sure, and if you took pre-calc, is if you're looking for a GCF already, there's 3 terms in there, and then if your coefficient of your x squared is equal to 1. So that's our SAM factoring method, which is reverse FOIL. Okay, so again, you still look for a GCF. After that, there's 3 terms, and there's a 1 in front of your x squared. So that's what we call our SAM factoring. Again, you can write as much or as little as you want, depending on where you're at. So SAM factoring is reverse FOIL. There would be 3 terms, and your coefficient of the x squared is equal to 1. So remember, that means the number in front of the x squared is a 1. And the reason why we use the acronym of SAM is because there are 3 letters and 3 terms with what we're doing. S stands for single x squared, single meaning 1. There's a 1 in front of our x squared there. Anyone remember what the A or the M stand for? Hopefully. Right. M stands for multiplies to, and A stands for adds to. So when we write our acronym SAM, 1 letter over top of each term there, that's going to help us remember that we're looking for 2 numbers that multiply to 40 and add to 13. So since this is reverse FOIL, we are always making 2 sets of parentheses. And then we're always thinking the F part of FOIL is what times what equals x squared in this case. Which is always our same answer. What times what is x squared? Gabe, how do we get x squared? All right, good. So this would be x times x. And that's how we get our x squared. And then we're thinking the M part stands for multiplies to 40 and adds to 13. So if you are stuck, write your factors of 40 out. 1 and 40. If I add 1 and 40 together, I get 41. If I subtract 1 and 40, I get 39. Can I use that? No. 2 and 20. If I add them, I get 22. If I subtract them, I get 18. Is that going to work? No. 3 does not go into 40. 4 times 10. I add that, I get 14. Subtract them, I get 6. So is that going to work? Nope. 5 times 8. When I add 5 and 8 together, I get 13. So I know it's going to be 5 and 8. I just have to double check my signs. They have to multiply to be positive 40, so they both have to have the same sign. They could be both be positive or both be negative. But since they're adding to be positive, they both have to be positive. And you can always double check with foiling if you're not sure. And then One more. Again, x squared minus 5x minus 14. If you're thinking of that flow chart I showed, we look for a GCF first. Okay. There is no GCF. There's three terms, and there's a 1 in front, so it's taking us to that SAM factoring method here. So once we know it's SAM factoring, we can write our acronym SAM over top. Again, we always say what times itself is x squared, or what times what is x squared. That's always going to be x times x. So now we're saying what multiplies to negative 14 adds to negative 5. So our factors of 14, 1 and 14, and 2 times 7, which is the only combination that could get us to 5. 2 and 7. So I know it has to be 2 and 7. But we need it to multiply to be negative 14. So that means one has to be positive, one has to be negative. It has to add to be negative 5. So which one's going to have to be negative? The 7. The larger one will have to be negative, and that means our smaller one's positive. Again, double check quick. 2 times negative 7 is negative 14. Negative 7 plus 2 is negative 5. So we're good. All right, so we have 5 minutes. You can start working on your homework. It is page 74, 1 to 9 odd, and then 17 to 22 all. Again, page 74, numbers 1 to 9. And then 17 to 22 all.